Kia ora koutou. I hope you're all doing okay. There we go. So hopefully the sound is coming through all good. Our plan for today is to talk about displacement reactions. Kia ora, kia ora, kia ora. I can see you all saying hello in the chat. Do not worry. I can see you as present and will mark you as such. So our plan for today is we're covering displacement reactions. Now, displacement reactions will be one of our last types of reaction to go through. So when we're talking about comparing those differences, hopefully you're already familiar with those other three types of reactions we've gone through. That is decomposition, combination, and precipitation reactions. Now, you'll notice at the top it's called a single displacement reaction. There are actually more complex versions of this reaction, which you can learn about if you stick around and do more chemistry in future. But we try and make it pretty simple for NCEA Level 1, so we just talk about the single form of displacement. Our goal for the lesson today is to explain to you what displacement reactions are and make sure that you can identify them and understand how they occur. So we're going to go through that, and then I'm going to outline what our tasks are for this week. But you can get a sense of what's going on here with the reaction that you're seeing here. Here you have an iron nail, and it's submerged in a copper sulfate solution. Now, when the iron is sitting in this copper sulfate solution, the iron is quite reactive, and so it goes in there and displaces the copper. As a result, you end up with iron sulfate and a layer of copper covering our iron nail. Now, copper sulfate is lovely in blue, whereas iron sulfate is this sort of greeny colour. And iron is a silvery, sort of greyish, dull metal, whereas copper is orange, as you will be aware. So the nice thing about this reaction is it's got all these sort of observations that you can make so that you know which parts are which. And part of your job when you're writing this internal will be to use those observations to identify the products and the reactants and to explain what it is you're observing. So then that's kind of the nice thing about displacement reactions. So let's dive into our content for today. This one will require you to take some notes, but our very first thing we're going to do is imagine a reaction here. So sodium hydroxide and zinc nitrate. Now this relates to what we were working on last week. So we're going to test out something that I've been doing with the juniors, and you're going to write the answer to this equation in the chat. So here are our reactants. I want you to write the products. So you have sodium hydroxide and zinc nitrate reacting together. Now you can think about these three things together, but I want you to focus on question 2. What are the two products, right? So have a go at that. I'll give you 30 seconds. For those of you watching the video, you can pause it now and try and see if you can write down that answer. At the very least, think about it in your head. So give it a moment. Sodium hydroxide and zinc nitrate. I want you to write down what the products of that reaction will be. I'll give you just a little bit of time here. You can imagine, a calm sea as you're trying to solve this. But please write your answer in the chat. When I see a couple of answers coming through, I'll move on to the next section today. So I'll let you think about that. For those of you who need a bit more of a challenge, you can be thinking about that third question, because you're going to have 2 products being made here. The question is, which one of them is the precipitate? So I'll give you another 5 seconds, and then I'm going to reveal the answer. 5, 4, 3, 2, 1. Okay. So the answer to this is sodium moves over with the nitrate, and zinc moves over with the hydroxide. So you end up with zinc hydroxide and sodium nitrate. So sodium nitrate, and zinc hydroxide. Those are the products that are made in this reaction. Kia ora, Lance, and kia ora, Sarah. So those are the products that are made in this reaction. The question is, which one is the precipitate? And you can check those answers with the table that's over there, those solubility rules. Now what you'll notice from the solubility rules is that zinc hydroxide is our first one, so let's have a look. Now, all hydroxides are insoluble. They're not able to be dissolved in water, except for potassium and sodium. Now, zinc hydroxide doesn't fit into either of those two exceptions, so it must be insoluble. Therefore, it's the precipitate. Excellent. Now, we can also check our other product, which is sodium nitrate, and double check that that is not a precipitate. And if you look at all the nitrates, all are soluble. So sodium nitrate will be soluble. That tells you that the precipitate that is indeed formed is zinc hydroxide. There you go. So were this to be a reaction, you would be able to identify that it is indeed a precipitate reaction. You would be able to identify those two products and be able to identify that the precipitate in this case was zinc hydroxide. All right, so today we're looking at these 2 points on the checklist, point 4 and point 7. So displacement reactions are exactly kind of what they sound like. They're when one thing displaces another in a reaction. In this case, a free metal replaces another metal in an ionic compound. Now, in order for this to happen, the free metal must be more reactive. And what do we mean when we say that? Well, there's actually a bunch of people who've done tests over time. What we found is there's kind of this reactivity series where some metals are more reactive than others. And sometimes when you place these compounds in a displacement reaction scenario, if the free metal is less reactive, then the reaction will not occur. However, if the reactant is more reactive, it will occur. An example shown down there for you: zinc, copper. Zinc is more reactive than copper, and as a result, it takes its place and the copper becomes free. So let's have a look at the reactivity series here. So reactivity is a measure of how ready something is to react. And displacement occurs when a substance that is free is more reactive than a substance that is part of a compound. Now you'll note that also carbon and hydrogen are included in here, and that's because technically speaking they can be included in this list. So copper, silver, gold and platinum are all less reactive than even hydrogen in this context. So hydrogen can take place in a displacement reaction from these. In the case of the types of things we'll be doing, we will likely only be using metals, but that's just there so that you know that that's the case. Now you'll be provided with this reactivity series when you're doing your internal, so you can have a go at understanding which types of reactions will take place and which won't. We'll have a couple of examples to work through at the end here. So our first example to talk about is copper and silver nitrate. So copper is more reactive than silver. Therefore, copper replaces or displaces, kicks out silver, and the silver goes into it either forms it usually forms like a silvery solid, right? So in this case, if you get yourself a copper wire and then get yourself some silver nitrate solution, which is sort of a lightish blue, if you leave that with the copper wire in it, what you'll see is that the copper leaves the wire and displaces the silver. And where does the silver go? Well, the silver has to form a deposit, so it forms this deposit on the wire and on the rest of the solution. So you end up making this copper nitrate solution, which is a much darker blue than silver nitrate. And so that sort of reaction is explained there, and so if you're thinking about that kind of excellence level explanation, this is basically what's going on here. Now, whoops, I flicked around. So, kind of just give it away a bit there, but here are 4 little reactions for us to work through together. Now your job on the slides itself is to write the word and symbol equations for each of these. We're just going to do the word ones together, but the symbol equations will be there for you to do, and it'll obey all the same rules around chemical equations that we normally do. So let's start off with the first one. So iron plus copper sulfate. So if we look here, we find iron is in the sort of middle position on our reactivity series. Is copper above it or below it? Well, let's have a little bit of a look. Copper is well below it. That means iron is much more reactive than copper. Therefore, iron will take place of the copper and will end up forming iron sulfate, and the copper will be left free floating, forming a kind of copper coloured deposit. If we look here, zinc and copper sulfate, same again. Zinc much higher than copper. In this case, the zinc would take place of the copper, and so the copper would form a coppery deposit. You'd end up with zinc sulfate. Our third one, magnesium and silver nitrate. Let's have a look here. So where is silver on our list? Silver is right down at the bottom, and zinc or magnesium way up at the top. Here we go. So magnesium is clearly going to displace the silver and form magnesium nitrate, leaving a bit of a silvery deposit on the side. Our last one here is we add zinc to some magnesium sulfate. Magnesium, we just discussed, right up the top. Zinc, a little bit lower. What that means is the zinc is less reactive than the magnesium, so the zinc will not displace the magnesium and no reaction will occur. And we can check our answers here, absolutely as we discussed. Iron sulfate is the compound that's made here with a bunch of copper left over. Zinc sulfate is made here, a bunch of copper left over. Magnesium nitrate is made here with some silver left over. But here, no reaction occurs because zinc is less reactive, lower down in our reactivity series than magnesium. So hopefully that makes sense, because that's all you really need to know about displacement reactions. The hardest part of this is making sure that you identify that the reaction that is in front of you is indeed a displacement reaction, and you can explain using this reactivity series why the reaction has taken place or why it hasn't. Additional things for you to do this week, outside of writing these 4 equations down. In your case, on your slides, it'll only be those 3. I added in that last one there to get you thinking, and making sure you've got those symbolic equations, because that's how you get those higher grades. There is some education perfect on displacement reactions, so I'll leave that there for you to work on. In addition to that, there are 2 major worksheets for us to work on. The first worksheet combines all 4 types of reactions together. So at this stage, you've hopefully understood these 4 different kinds of reaction, and you can identify which one is occurring and then explain it using the information that we've been going through. You might find that for one kind of reaction, you have more difficulty to explain it than the other ones, in which case I recommend spending some more time on that one, or you can bring any questions you have to it to our Google Meet. For some of you, you'll be feeling pretty advanced. You'll be able to fly through this reaction worksheet. For some of us, it will take a bit longer. But if you're finding you're flying through this, then I'm going to give you some merit and excellence level stuff to work on. So the merit and excellence level is another worksheet there. And this is about comparing and contrasting. So in order to get the excellence, you will have to compare and contrast reactions. And one of those reactions that you'll be comparing and contrasting will be a precipitation reaction. So you want to make sure you have a good understanding of what we covered last week. So you will be given 2 different kinds of reaction, and in the worksheet that is exactly what you're given. And your job is to talk about how the reactions are similar and how they're different. Now your job will be to use chemistry vocabulary when you're doing this, right? So that's all the kind of terminology that you're probably familiar with now. The idea of spectator ions sitting in solution watching, the idea of solubility and insolubility, the idea of what ions are in general, maybe even the idea of a reactivity series that we've covered today. In this, you've got to include these things that are here on the right, so that's there for you to make sure that you're including that when you're answering that worksheet. And the reason why we've put these things here relates to our next slide, which is our final content slide for today. And this is actually what the internal is going to be assessed on. So you'll notice that in order to get an achieved in this, you need to provide the formula for different reactants, right? You need to explain an observation of two different reactions. So that's you kind of saying, I saw that there was a silvery substance and the reaction happened because afterwards there was a copper-colored substance. That sort of thing, right? You also want to be talking about solubility rules. So that relates to our precipitation reaction, the idea that some substances are soluble and some are not. And we know that because we've done lots of testing and we've got a nice set of rules that we can follow to check if things are soluble. The actual reasons for this we explore at level 2 and level 3 chemistry, and it's pretty interesting, but it's also quite complex. So we're just introducing to the idea that we know some substances are soluble and some aren't, and there are general rules that we can follow. You want to be able to correctly classify different kinds of reactions, and they note there one must be the precipitation. So if there's one area that you must focus on, it's that understanding of our concept from last week. There's also the understanding that in order to pass this, you kind of need to use the terms that we've been talking about. So that idea of what is soluble, what's a solute, what is a solvent, what's an ion, all of that sort of thing. Notice there's also two-word equations for two different reactions. So if you're only looking to get the achieved, then make sure you're super comfortable with those word equations. And if you're having any difficulty with that, you can fire any questions away. For those of you going for merit and excellence, as we talked about before, you can use these ideas here as the focus for us to work on. It's about explaining the why you have seen what you've seen, and like linking together your observations, your equations, all of this sort of stuff, and then looking to do symbol equations and then to balance those. This compare and contrast section is the excellence level requirement that distinguishes a merit from an excellence, right? And there's some details about how to do that. So that brings us basically to the end of the content for today. There wasn't too much to go through. Our 4 major tasks to go through are to make sure you understand the concepts that have been explained, and to have a go. Those 3 practice equations that we went through together, I recommend having a go at the symbol equations for these. It's good practice. Then there's some Education Perfect, which covers the concept that we've just discussed, but in a different way. And so if you're able to do either or both of those, you'll have a pretty good understanding of displacement reactions. You then want to have a go at the 4 different kinds of reactions worksheet, which is essentially what the final internal is going to look like. And then there's an opportunity there for those of you who need that kind of extension, who are ready for this challenge, to have a go at that excellence compare and contrast stuff. So that does it for us today. I hope that you find the content okay. If you've got any questions, I will hang around for a minute or 2 in the chat, so you can ask me anything, or you can bring them along to our Google Meet later this week, or alternatively, you can just send me an email. All right. Thank you very much for your focus and attention today, team. I will catch you all later. Ka kite.